Okay, we'll start with the applications of divisibility rules. Okay, now if you come to the applications, means where we are using these divisibility rules, where do we use them? Where do we use something that is called application? Okay, and so let me give you a simple question, you will understand. Now let's imagine that we are given a number 4x2. For this number to be divisible by, for this number to be divisible by 2, what should be the value of x? I want this number to be divisible by 2, what will be the value of x? What is x equal to? Can you try answering this question? What is the possible value of x if I want this number to be divisible by 2? It is not multiplication. This is not multiplication. This is like this. 4a2, what is the value of this a, so that the whole number, this is a 3-digit number. Okay, it's a 3-digit number and the whole number will be divisible by 2, and in that case what is the value of this a? Can you tell me? Okay, I'll explain this question. Now what is the rule for divisibility by 2? In the units place, you need to have 2, 4, 6, 8, 0. If these are there in the units place, then I can say that that number is divisible by 2. Now if you look at this 2, clearly this number, irrespective of what is written here, is divisible by 2, right? So I can say that 402 is divisible by 2, 412 is divisible by 2, 422 is divisible by 2, 432 is divisible by 2. Means in A's place, if I write anything 0, 1, 2, 3, I can say that 4a2 is divisible by 2. I hope you got this question. You will get some questions of this type also. I hope this question is clear to everyone. Okay, nice. Now we'll try to solve another similar question. Okay, just take this question and try to answer me. Fine, and the answer should be from your side. 5 to a. What is the value of a? What is the value of a if number to be divisible by 9? If I want this number to be divisible by 9, then what should be a equal to? Now I'll give you a hint how you will solve this question. You remember what is the divisibility rule of 9? You remember this part? I hope I am audible. Wait for some time. Just try to solve this question and tell me what is the possible value of a. I'll tell you the rule. For 9 to be divisible, sum of digits sum of digits should be divisible by 9. Should be divisible by 9. This is the rule. For this number to be divisible by 9, sum of digits should be divisible by 9. So can you tell me what is the value of a? Yes, I have got an answer. Yes. Value of A will be equal to 2. So the number is 522. Alright. Now can you tell me what are the possible value of A if you want this number to be divisible by 3? If you want this number to be divisible by 3, what are the possible values of A? Now, I want this number to be divisible by 3. What is the value of A? So what is the rule? When you take the sum of all the three numbers, it should be divisible by 3. That is the rule. So, how will you find the answer for this question? You can see 5, 2, 0. This is not divisible by 3. 5, 2, 1. This is not divisible by 3. 5, 2, 2. If you add 5, 6, 7, 8, 9. Yes. 9 is divisible by 3. That's why 5, 2, 2 is also divisible by 3. Similarly, 2, 3, 4, 5, 2, 5. This will give me 12. 12 is divisible by 3. 6, 7, 5, 2, 8. You check this one. 8, 9, 10, 15. 15 is divisible by 3. So, now can you tell me what is the possible answer of A so that it is divisible by 3? Yes. Monisha has given the answer. It is 258. Yes. 258. That's correct. Right. Now we'll solve another question. These all are applications of divisibility rules. Means you need not check for all the possibilities of A. You can simply find out what can be the value of A just by using the divisibility rule. Okay. Now we'll try to take another example. X35. I want this number to be divisible by 5. What is the possible value of x? Now, what is the possible value of x if I want this number to be divisible by x, divisible by 5? So what is the rule of divisibility for 5? Unit place should have either 0 or 5. And you can see in this number clearly the units place is 5. Yes, it can be equal to, it can be equal to 0, 1, 2, 3 and so on, right? So this is the answer. In the same way, we can solve such questions depend if you know the rule of divisibility faster. Okay. Now I'll have some more questions. These are different type of questions. Okay. Simplifying simplifying calculations. We'll use divisibility rule for simplifying calculations. Okay. Now if you get a question, is 102 divisible by 6? Is 102 divisible by 6? This is a straightforward question of divisibility example. Okay. And you know the rule. If you want to check whether a number is divisible by 6, you need to check for divisibility by 2, and then you need to check the divisibility by 3. So when you multiply these both, you are getting 6. So I can say that, and here there is some important concept I'll explain you. concept of co-prime numbers. Co-prime numbers. Okay, I will tell you why I am explaining this. This co-prime numbers will explain us. Okay, before going to the application of co-prime numbers, I'll tell you what is co-prime number. It is set of two numbers whose HCF is 1, means highest common factor is equal to 1. Okay, it is set of two numbers whose HCF is 1. I'll take an example. I take example of this 2 and 3 only. 2 comma 3. What is the HCF of this? HCF of these two numbers? What is HCF of 2 and 3? Highest common factor. How do you find highest common factor? Highest common factor also has lot of applications in the mathematics. Okay. Highest common factor is also called as GCD. Okay. Greatest common divisor. Highest common factor, greatest common divisor, both are the same thing. Okay. Now I'll tell you how to find this. There are two methods to find the highest common factor for any given set of numbers. Now 2 and 3. Find the factors of 2. What are the factors of 2? What are the factors of 2? Means 2 is divisible by which all numbers? 1 and 2. 1 and 2. Okay. There is some issue with the system. I'm planning to buy a new one. Maybe within 2 days I'll get it. Okay. Just adjust for today. Today, tomorrow. Okay. Now 1 and 2 are the factors of 2. Now what are the factors of 3? What are the factors of 3? 1 and 3. It's simple. Okay. Now you need to find among these factors which is greatest and common, or highest and common. Both are same, right? So which is greatest and common in both of these factors, set of factors? Obviously 1. So 1 itself is the HCF of these two numbers. Okay, 1 itself is HCF of these two numbers. Now similarly, if you take example of 2 and 8, and if you are asked to find the HCF, how will you find? You will take 2, find the factors 1 and 2. You will take 8, find the factors 1, 2, 4, 8. So now can you tell me what is the HCF of these two numbers? HCF of 8 and 2 is 2, right? So from the name itself it is very clear that this is going to be the highest common factor, or highest common greatest common divisor. Okay. Now why I explained this concept was, by using this method you will be able to identify the co-prime numbers. So 2 and 3 are co-prime numbers because HCF is equal to 1. Now can you tell me 2 and 8, are they co-prime numbers? Are they co-prime? No, right? Because HCF is not equal to 1. So 2 and 8 are not co-prime numbers. Now can you tell me 4 and 3, are they co-prime numbers? 4 and 3. Can I say 4 and 3 co-prime numbers? No. Yes. Because HCF of these two numbers is 1. Now you will understand what is the application of this. Now let's imagine that you want to find the divisibility rule for 6. Okay. Now you can check with two such numbers whose HCF is equal to 1. Now if the number is divisible by 2 and 3, then I can clearly say that that number is divisible by 6, because these both are co-prime numbers. Okay, that is the requirement for these two numbers. Okay, now you take another simple example. You take 12. 12 is actually divisible by 6, 2. Now you see, if I multiply this 6 and 2, you are going to get 12, and you have got another set which will give you 12. That is, can you tell me another set which will give you 12 on multiplying? Set of two numbers on multiplying that will give you 12. That is 4 and 3. Now I cannot check the divisibility of any number using these two numbers. Not possible. Because if a number is divisible by both 6 and 2, I cannot say that that number is divisible by 12, because HCF of these numbers is not equal to 1. It is equal to what? HCF of 6 and 2 is equal to what? Yes, it is equal to 2. That's why I cannot check divisibility of 12 using these two numbers. But you observe this part. What is the HCF of these two numbers? It is 1. And so I can call this as co-prime numbers. And therefore I can use these two numbers for checking the divisibility by 12. I'll take a simple example. Okay. Now if I take 18 and try to check divisibility, whether it is divisible by 12 or not, using these two numbers. This number is divisible by 6, true. This number is divisible by 2, this is also true. But this number is not divisible by 12. I hope you got this concept. For checking divisibility by any number, you need to have co-prime numbers so that the rule is applicable. You cannot check divisibility by 12 using 6 and 2 because they are not co-prime numbers. Okay. Now, so 18 is not divisible by, according to, actually it is not divisible by 12, but these both are dividing 18. That's why there is some contradiction. But now check by 3 and 4. Check, is 18 divisible by 3? Is 18 divisible by 3? Yes, it is divisible. Now next one is 18 divisible by 4? No. Therefore, I can say that 18 is not divisible by 12. So you will require co-prime numbers to check divisibility of any number. I hope you got this concept. Okay. I hope this concept is clear. How you will use the co-prime number concept to check the divisibility. I cannot check divisibility by 12 using 6 and 2. Okay. But I can check divisibility rule using two co-prime numbers. Okay. Now we'll go to the next concept. Okay, next application. It is also very interesting. Identifying prime numbers. Identifying prime numbers. Identifying prime numbers. Wait for some time. The system gets overloaded. Identifying prime numbers. Now you'll get a question direct straight away like this. Check whether 47 is prime number or not. Prime or not. To solve such questions, what is the naive way of doing it? Naive way means, what is the obvious way of solving this question? What you will do is, you will take this number and you will keep dividing it by 1 Okay, not 1, and you'll exclude 1 and 47, and other than 1 and 47 you go on dividing. Divide by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 till 46. If it is divisible by any of these numbers, then I can say it is not a prime number. It is not prime number if it is divisible by any of these numbers. Because what is the definition of prime number? This is divisible by only two numbers, that is 1 and the number itself. 1 and number itself. That is the definition of prime number. Okay. If you want to check whether a number is prime number or not, you need to find a third value. You need to find a third number that can divide this one. I hope the definition of prime number is very clear. Okay, okay, that is prime, that is correct. But how will you identify that given number is prime or not? Using simple steps. Now solving 47 is simpler. Now if you take a bigger number like 123, how will you check this one? So it is obvious that this is divisible by 3, that's why this is not a prime number. Okay, but if it is 127, how will you check for this? For that you will require a rule, a simple method. Okay, now let me explain you using this 47. What we will do is, we will try to find square root of 47. Okay, you cannot find the square root of 47 that easily, but you can just find the nearby value. So I know the square root of 36, I know square root of 49. So square root of 47 is lying in between what? Yes, it is lying somewhere in between 6 and 7. So it is 6 point something. So square root of 47 is 6 point something. What you do is, you find out prime numbers that are less than 6. So what are the prime numbers less than 6? 1, sorry, 1 is not a prime number. 2, 3 and 5. So check divisibility by only these three numbers. If it is not divisible by three numbers, then I can directly say that 47 is a prime number. You got the concept? You take the square root of these three numbers, you take the square root of any given number and try to find the prime numbers lesser than that number. And if the number is not divisible by any of these prime numbers, then I can straight away say that this number is not divisible by 47. Now what is the benefit of this method? Benefit of this method is, you need not check divisibility from 2 to 46. There are almost 44 numbers, but I have reduced this 44 from, I have reduced this from 44 to 3 using this concept. Okay, this concept can be used in any number, any case. Okay, any case, and you will be able to solve the question. Okay, I hope you got this concept. We'll solve some more questions so that you will be able to tell whether a number is prime number or not using simple steps. Okay, now we'll take an example here. We'll take another example. Now we have got 53. Is it prime? How will you check? Take square root of 53. So this is going to be something like 7 point something. Okay, this is going to be 7 point something. So you are going to take a set of prime numbers which are less than this 7, including 7 also. So it can be 2, 3, 5, 7. Now you will check whether 53 is divisible by these numbers or not. 53 is not divisible by 2 because the last number is not equal to 24680. So not divisible by 2. Is it divisible by 3? 5 plus 3, 8. 8 is not divisible by 3. That's why it is not divisible by 3. Again 5. Unit place should be equal to 5 or 0. So it is not divisible by 3. 5. By 7, you will multiply this by 2 and subtract from this 5. What is the rule of divisibility for 7? You will multiply this 3 by 2, so you got 6. Subtract this 6 from this 5. 5 minus 6, you got minus 1, and this minus 1 is not divisible by 7, therefore 53 is not divisible by 7. So can I say 53 is a prime number? Yes, 53 is a prime number. You got it? This way you can check whether a number is prime or not.